Right. Hello, everyone, and welcome to this presentation called Keeping People and Society Safe Using AI to Improve Situational Awareness. And I realized that I do not have the clicker thing. Thank you. Great introduction. I would just, to kind of keep the timing of my slides and the timing of everything, do a quick introduction of myself. My name is Christian, and I work at Saab as a software developer. And I've been part of this project where we are integrating large language models into an intelligence platform for situational awareness. And just to get started, a quick sort of overview of what Saab is and what we do. We do not do cars anymore. As we mentioned here, we are working in many different domains in the defense industry with a large range of products there. So that sort of affects how we think about and how we work with this type of technology that I'm going to be talking about today. In this presentation, I would sort of go through how we worked with a proof of concept using NVIDIA technology, and where we wanted to sort of answer the question, how can an intelligence platform be powered by large language models? And as I mentioned, this was all based on NVIDIA technology, both hardware and software, and we also had a lot of help from experts in the field from NVIDIA. Some of them are here today as well, and yeah, they really helped us kickstart this project and keep us on our time track here. So sort of to set the scene, we set up a new team, including me and some of my colleagues. We worked with, for us, new technology, such as large language models and AI agents, and we had a limited time frame for this project that we were working on. And we wanted to integrate this technology into an existing intelligence platform that we have to work with, and sort of the idea, or sort of what we wanted to achieve here was to go from clicks to conversations. Massive Data Fusion, which is the name of this intelligence platform, is a platform that has a lot of data in databases, and it has this graphical user interface allowing the users to visualize and sort of search through this data. And we wanted to do something else. We wanted to change the way we interact with this system, interacting using conversation and questions asked by the users instead. And this was all powered by large language models running on NVIDIA NIM technology, where we could have conversations not only with the system, but also with the data in the system. And sort of the key takeaways that I sort of want to highlight in this presentation is how generative AI impacts user interface design and how generative AI will change the way that we interact with our data. And I will sort of have two parts of this presentation. First, where I go through sort of how we worked with this, and then the second part, I will go through a little bit more in detail how the system works and have a short demonstration about the demonstration video of the system in action. So, Massive Data Fusion, the intelligence platform. It is able to take and ingest data from multiple different types of sources. Could be sensor data, it could be satellite images, or any other type of data that has a geographical position and a timestamp. And what Massive Data Fusion does is it takes this data and sort of fuses it and starts building knowledge over time. So we can use this historical data to sort of try to predict the future and how the state changes in our system. And we can also use this data to do all sorts of data analysis, try to predict, to find anomalies in the data and stuff like that. So there's a lot of things you can do with this platform. And when we work with the large language models, integrating this into such an advanced and complex system, it can be very challenging. There's a lot of functionality. We have a lot of different types of data sources available. So we early on decided to sort of narrow the scope down a bit and focus on a single scenario that we created, following a sort of fictional story where we followed through a series of questions and answers to the system so that it would be easier to evaluate our models, and it would be easier to sort of focus on a set of tools that the Massive Data Fusion platform provides in our large language models. And the fictional story is sort of a Coast Guard scenario. We are using ship transponder data, AIS data, and we imagined the conversation and the sort of scenario to look something like this. The user will ask a question: please show me ships that stop longer than 30 minutes outside coastline X over the past 6 months. And the system would then interpret this, translate this into whatever necessary tool calls to solve the problem and fetch the data and provide back an answer. The user could then start, asking follow-up questions, such as, has there been any vessels anchoring in a port or something like that? And we can start to create this sort of interaction between user and system in a more conversational way. And this type of interaction is actually something really interesting and something quite new. Nielsen talks about AI in using AI in this way is a new UI paradigm that, and we haven't had a new one in over 60 years, where we're going from command-based interaction, users telling the system what to do to achieve the results that the user wants, and we go towards a new paradigm with more intent-based outcome specifications, where the user instead tells the system what they want to achieve, and then it lets the system figure out exactly how to achieve that and get the results that the user wants. And this new way of interacting with system led us to early on have a user-centric focus, where we sort of conducted workshops based on this user scenario that I talked a little bit about. We had the user group interviews with expert users of similar systems, and we created interface mock-ups to sort of try to figure out how to best use this system and how to best interact with them in this new way. And the key aspects that we could take from this process was the importance of human and AI teaming. We are in the defense industry, so having human some sort of human interaction or involvement in the process is very, very important, especially to our users. And we also want to highlight, the importance of trustworthy AI. The users of our systems, being a very critical system as they can be, they need to be able to trust the information that the system is giving them. They need to be able to trust the calculations that the system is doing, and it needs to know that it can follow through step by step what is happening and how the system can come up with the results that it has. So it has been a fine balance to try to discover and try to get to know the perfect balance here between what tasks can the system perform, what tasks do the humans and the users have to perform, and where can we have sort of this mixture where the system can do most of the work but have some sort of human confirmation part. So that has been a big part of this project, to sort of explore that and figure out how to best handle this new way of thinking. So that is sort of the more of the process part of this presentation. I will now go in a little bit more into depth about the system that we have created. What we see here is the Massive Data Fusion original user interface, and we have transformed this into something else, where we focused on this large language models as our way to communicate with the system using this chat window. And I will show you more about the system in the demonstration later, but I'm going to talk a little bit about the work process in this project that I've been part of. So we started this project with doing a lot of research in the area, started experimenting with the frameworks that we've been using, and just getting to know these LLMs and how to extract the information that we want from them and what to do. And this resulted in us creating our first agent, being a search agent able to translate user questions into pretty much search API calls in the Massive Data Fusion backend. So we integrated this agent into our system together with this chat window and started working on the graphical user interface improvements, and quickly started to add more and more agents. into the system, because we need more agents to get to use more tools, because the more complex the problem becomes, the more the agents will sort of start to hallucinate. So we want to keep them as simple as possible, to really focus on a single sort of objective or tool for them to use. And in sort of a final phase in this project, we had our system of agents with their specialized tasks. We started to work on improving the quality of the answers and also increasing the consistency of the system by introducing a little bit more advanced concepts, such as guardrails, using this judgment system where we let the LLM judge the work of the others LLMs. And we also started to utilizing user feedback to sort of improve the system the more we use it. And I thought that we would sort of follow along a simple question in the system. So we have this overview of what the system kind of looks like, with the graphical user interface to the left, with the chat window and the user feedback module. We have sort of the AI assistant with the agents in the middle, and then we have the rest of the massive data fusion application to the right. So what would happen here is that the user would enter their search query into the chat, and that search query would be sent to the AI assistant through these guardrails functionality that we have implemented. And what we do with these guardrails is that we set a policy of what type of information that we want certain parts of the system to be able to handle or to be able to process. So for example, if we add these guardrails to the user input, we can make sure that we catch questions that are not maybe relevant to the system's use area, or we can catch messages that are used to try to sort of break the system. And we can also use these guardrails to sort of guard the output from the LLMs and from the system by setting up policies to sort of catch hallucinations and stuff like that. So the user question will go through these guardrails and enter the supervisor agent that we created, that has been tasked not to try to solve the problem or answer the question, but rather to come up with a plan using the capabilities of the system and the agents of the system to solve that issue or that question. And once this plan has been finalized in this supervisor agent, the other agents in the system will start to work with their specialized tasks to try to solve the question. So for example, if a user is asking for some new data, this search agent would be included in the process, and maybe we need to do some filtering or maybe some data analysis. So depending on what kind of question the user is asking, different part of the system will be activated and will be used to try to answer the question. And once these tool calling agents have done their work, all the information that the system have generated and fetched will be sent to the finisher agent, who will then try to come up with a response back to the user to sort of finalize a response based on the information that we have. Maybe include some insights, include some summarization of the information, or stuff like that. And this is one of the agents that we included this judgment system as well. So we have these additional LLM that will sort of examine the work of the finisher and provide some feedback on how to improve that work to sort of match a certain criteria that we set up. So this is like a process that we can do multiple times, trying to improve the quality of the answer more and more. And this answer is then sent back to the user in the interface, and the user can use the feedback module to sort of provide some feedback on what they thought, if the user thought the answer was good or not, so we can store that information and use that in the system in later questions. So this sort of allows us to create a database of questions and good or bad answers to use as a sort of a baseline in our system to sort of improve the system the more we use it. So this is sort of like the system that we've created. And now I'm going to show you a short video where I demonstrate how the system works in real life. And as you will notice, we are using speech-to-text here as well. So you will be hearing my voice recorded, asking some questions to the system, trying to sort of find some suspicious activity going on in the Bay of Biscay. And I will try to do some live commenting as we go along here as well to sort of explain what is going on. So let's get started.
Can you give me some data in a 150-kilometer radius in the western parts of the Bay of Biscay on February the 2nd between early morning and noon?
Right, so the question would be visualized in the GUI, and we can see sort of in this gray box the process the system is going through. You know, planning a new course of action, do some revision of that plan to make sure that it's correct, and then we will start utilizing the tools we have. Searching for data, in this case, in the area of the Bay of Biscay. This information will be displayed in the map part of the GUI as well, and the system will start generating an answer back to the user, sort of including a summarization of the data that we're looking at, some extra interesting aspect that the system has found in the data, and it will also try to suggest some further actions to sort of start analyzing the data that we have, or how to sort of ask follow-up questions to continue the information gathering.
Can you find out if any of these ships have met out at sea?
So the follow-up question I ask here is to find out if there has been any meeting occurring out in the sea in this data. And this will trigger the system to look at each of the data points that we already have, conduct a new searches to find more historical data about each point, and then do some analysis to find out whether or not they have been standing still next to each other or just been moving slowly next to each other for an extended period of time. And luckily for us in this demo, we find one such meeting. And the system will then sort of give us a summarization of this meeting. You know, it's been between these two vessels. They have been meeting for approximately 25 minutes, and it will once again suggest some further actions, including us analyzing the frequency between these two vessels to find out if they've been meeting in other places in time.
Let's search for some additional data to find out more about the movement of the ship called Loud Sterling between February the 2nd and February the 5th. I am specifically looking for any suspicious activity related to the ship.
Right, so I asked for some more data for one of these ships, Loud Sterling. And I also add a special command at the end there where I'm asking the system to look for suspicious information or suspicious data. And this will trigger the system to do some additional data analysis, looking at the data points that we have and try to find some anomalies or deviating data points in the set of data that we find. So we can sort of see the trail here in the system, and the system will do the data analysis and start generating a response based on that analysis. And shortly, yes, we will see that the system has found a couple of anomalies in this data. If we were to look down in the Bay of Biscay again, one of these anomalies will be displayed there in the form of an acceleration anomaly, where the ship suddenly slowed down to have this meeting down in the Bay of Biscay. And if we look closely at the map, we will also see that there is another such meeting near Brugge, or another such anomaly where the ship has suddenly slowed down that would sort of indicate that another event has occurred there. And what I sort of want to highlight with this video is the new way of interacting with this system, interacting with the data that we have, that I believe is sort of a stepping stone towards this new paradigm in the user interface. And the way that the users can sort of interact with the system changes the way that users have to think about utilizing systems like this. So it's a very interesting thing to be working at. And sort of like a final remark here, I've been working with systems like this, and it's super exciting to see everything evolving over time here. It goes really fast, and I am really excited to be part of and see how this evolves in the future. Thank you very much.
Thank you very much, Christian. Yeah, the stakes seem to be pretty high in your field. Do we have questions from the audience, please?
We have one question here.
Perfect.
Thank you. One question is, you mentioned that certain words trigger the additional analysis of data to detect anomalies. Could you please elaborate how it is implemented?
How the anomaly...
backend? Do you have a vocabulary, or what is the trigger mechanism?
To do the anomaly detection.
Yeah, or additional data analysis.
All right, so Some of the analysis we can perform using the LLM's capabilities by their own. It really depends on how much data we have currently in the system. In the example here, we saw there was quite a small amount of data, but this system is capable of generating much, much more data for us to handle. So in those cases, we need to sort of have some algorithms in the back end that the models can call upon to help them in the analysis. So it sort of depends the type of analysis that you want to do. I hope that answered the question. Right?
Thank you. Do we have another question for Christian?
Yes. Hello, yes. So you mentioned that between the AI assistant and the graphical UI, you had a NEMO guardrail system. You also mentioned briefly that it could do things like detect hallucinations. I was wondering, how does it do that? Do you have like another agent that does it, or is it more a deterministic thing where it checks something with a database, or how do you know if something is a hallucination?
No, so that is it's agent-based checking. So we define policies to for the guardrails to look at, and then it can just check that list and see. So in the hallucination case, maybe we have some sort of data that it needs to look at to sort of cross-reference and check that it's actually correct, based on the information that the system have generated, pretty much.
Okay, thank you.
And we actually have time even for another question.
I have another question up here.
Great.
I'm over here.
It's very hard to see. Okay, there. Thank you.
I noticed you removed the old user interface.
Right.
Did you evaluate afterwards if this new interface covered all the needs, or is it still there for the users if they need it?
Right. So this, of course, in this current state, does not cover all the needs of the application. As I said, we needed to narrow down the scope, so we have just a subset of the functionality. And most likely, in the future, replacing the entire user interface with this chat window is probably not what we want to do, but we want to keep some of the elements left, right? It's just for simplicity and making it more presentable, sort of. And also, we wanted to explore, how does this affect us? Can we really replace everything with this chat window? And the answer is probably not, right?
Thank you.
Yeah.
And we have another question here at the bottom, and this is just what I can see. I'm sorry for missing. Yeah, this is the last question.
Thank you. In your demo, you showed you asked a question about HMS something. I don't remember what it was called, but I think that's the British military vessel.
Did it say HMS in the GUI?
Yeah.
Okay.
So I was wondering, what type of data are you allowed to gather?
All right. So this is, this is just AIS ship transponder data that we've been using partly, and we have also partly been using synthetic data. So it depends a little bit about, what we're using, but the AIS data is just open data. I mean, all ships have to send out this information, and there's a lot of services to collect that information and use it and sells that to companies and stuff like that. So, the type of information that we are allowed to collect, that is, I can't really answer that question here, sorry, but we have been using open data in this example. Yeah.
Well, really, thank you very much for bringing so much clarity on this very specific domain. And please accept flowers from Gaia.
Thank you very much. Tackar.